So now we're going to move on to compound probability. Compound probability is the likelihood that two separate events will occur, that both the events will occur. The way you find the compound probability is you find the probability of each separate event and then you multiply them together. So for instance, our first example is where we have compound probability if you draw two cards, but you do not replace the first card back into the deck. So we have 52 cards in each deck. And so let's look at number 6. What is the probability of drawing an 8 and then a red jack? If we have 52 cards in the deck and we have 4 suits, so they're 4 8s, so that's 4 over 52, that reduces to 1 over 13. We did not replace that card back into the deck, so now we only have 51 cards. And there's only 2 red jacks. So that would be our problem. So 2 times 1 is 2. 13 times 51 is 663. So now I would like you to pause your recording and try to figure out 7 and 8 independently. And then come back and we'll check it together. Okay, so we're looking at number 7. What is the probability of drawing a face card and then a red 7? So there are 3 face cards per suit, Jack, Queen, and King. And so there's a total of 12 out of 52. That reduces to 3 over 13. When possible, go ahead and reduce your fractions because then it makes your multiplication problem much easier. Now we only have 51 cards left in the deck, and there's only 2 red 7s. So 2 times 3 is 6, 52 times 13, 51 times 13 is 663 again. I'm going to reduce that. I know 3 goes into both 6 and 663, so that reduces to 2 and 2, 21. So out of every 221 times you draw 2 cards out of the deck, you're going to get a face card and then a red 7. So what is the probability of drawing an 11 and an ace? So I want you to think about that for a minute. There is no such thing as an 11 in a deck of cards. I do realize that in some cases they'll use an ace maybe for 1 or 11 or a jack in some games, but in our purpose, when you look through a deck of cards, there is no 11 anywhere in the deck of cards, and that's important to know for future reference in case you're asked that in a question later. So there's 0 probability of drawing an 11 because there just isn't one in there. We don't have to figure out the second event because if the first event doesn't happen, there's no way that both events can happen. So now let's go down to our examples down here at the bottom of throwing a dice. So we have one 6-sided die that we're going to roll and a 2-sided coin. So even number P, what's the probability of rolling an even number in heads? Well, there's 3 even numbers on a 6-sided die, 2, 4, and 6. So we have 3 out of 6 chance of rolling an even number, which that reduces to 1/2. And when you flip a coin, you have a 1/2 probability of getting heads. 1 times 1 is 1, 2 times 2 is 4. So we have a 1 in 4 probability of rolling an even number and flipping a coin and getting heads. So again, at this point I would like you to pause your recording and work through 10 through 13, and then come back and check your answers. So hopefully you've worked through 10 through 13, and so let's do them together. So the probability of rolling a 6 is 1 out of 6. Tails, again, is 1/2. And so we have a 1 over 12 probability of rolling a 6, and then tails. Now prime numbers on the die are prime numbers or any numbers that are only divisible by themselves or 1, not including 1. So from 1 to 6, our prime numbers are 2, 3, and 5. So we have 3 prime numbers. Again, that reduces to 1/2. And then we have heads, so that's another 1/2. So that's 1 over 4. Now, number 12, a number less than 5 would be 1, 2, 3, 4. So we have 4 over 6. That reduces to 2/3 times 1/2. To 6, and that reduces to 1/3. A number greater than 1 on a die, we have 2, 3, 4, 5, so there's 5 out of 6. And our heads, 5/12 possibility of rolling a number greater than 1 and flipping a heads. So now let's go to page 4. Where we have Miss Smith with her bag, 2 bags of candy. Miss Smith has 2 bags of candy. In the first bag of candy, she has Lifesavers. She has 6 red, 5 yellow, 8 orange, and 9 white. Now, in her second bag of candy, she has candy bars, where she has 3 Butterfingers, 3 Snickers, and 4 Hershey bars. Find my pen. So what is the probability of her drawing a yellow Lifesaver from one bag and then a Snickers from the second bag? Well, think about the first thing we have to do when we're figuring out probability of drawing the Lifesavers. We need to add up all the total number of Lifesavers. So we have 9, 6, 5, and 8, 28. And that adds up to 28. So we have 28 Lifesavers, and we look up here, we have 5 yellow. Now let's look at our candy bars. We have 3, 6, and 4. We have 13 total candy bars, and there are 6 Snickers. I'm going to reduce before I multiply because it makes my multiplication easier. You can cross-reduce before you multiply, and I'm looking at 28 and 6, and I know that 2 goes into both of them. 2 goes into 6 3 times, and to 28 14 times. Now I multiply 5 times 3 and I get 15, and 14 times 13 is 182. Now I'd like you to pause and work on 6 and 7 independently, and go ahead and work on the bottom 10, 11, 12, and 13 also, and then come back. Okay, so we're on number 6. We're looking at the probability of drawing a red or orange Lifesaver in a Hershey bar. And we're going to look up here. There's 8 orange, there's 6 red, so there's 14. I'm going to do the work down here. 14 over 28, and that reduces to 1/2. And then we have our Hershey bar. We have 13 total and candy bars and 4 Hershey's. So again, I'm going to reduce before I multiply. I know 2 goes into both 2 and 4. 2 goes into 2 once, 4 twice. 1 times 2 is 2. 1 times 13 is 13. Now, not white. What's the probability of drawing it not white in a Butterfinger? Well, if there are 9 white, that means there are 19 that are not white. We still have our total 28. And we have 3 Butterfingers. And if you do the calculations on that, that multiplies out to be 57 over 364. So now let's look down at the bottom. They said that David rolled a number cube with the numbers 1 through 6 on it. He recorded the results in the table below. So it gives you all his results and how many times he rolled. But then it says find the following theoretical probabilities. They're not asking for the experimental. They give you all this experimental data, but we actually want to find theoretical. So make sure you always read the question. So what is the theory of rolling a 4 on a 6-sided die? 1 out of 6. We already did these on the other page. An odd number is 1/2. A 2 over 5 is 2 over 6, which equals 1/3. And a factor of 3, or 2 factors of 3 are 3 and 6. And that would be 2 6, which equals 1/3 also. So make sure you read the question. I had a lot of students who added all these up and then did, 6 over the total number for probability drawing 4, when really all they wanted is the theoretical, not the experimental. So I hope that helps. Try to work through the rest of the packet the best you can. Pay special attention to when it says do not replace a card or a marble, because that's going to change your denominator for your second probability when you're doing compound probability. Okay, hope that helps.